Here we have the center off of the origin. It's not on the origin. So it's 1 and then -2. Right there. And the radius is 2. That means it's going to look something like this, right? Like that. Right? So you see that radius is 2 right now? From there to there is 2. Okay. So I want to know what kind of constant relationship these points have, right, between x and y, the x coordinate and the y coordinate. Well, visually, because it's a circle, we know this. Any point on here, let's call it xy, the distance to not the origin this time, to this center, which is 1, -2, must be always 2. Make sense? Okay, so let me write. Okay, let me exaggerate. Let me put this point up here. Okay, let me extend the line down from that point perpendicularly and extend the line across perpendicularly. Okay. Now, what is the expression of this length here? If that point right there is xy. Okay, if that point right there is xy. Okay, so this x is referring to here. From there to there is x, right? True? This x is referring to there, right? I want to know the expression of this. Do you see that it's going to be x minus 1? From here to here is 1. So this must be, that right there must be x minus 1. What about this height? Okay. Do you see that it's going to be, so that right there is y. Okay. That right there is y. So it's going to be y, and you got to further go down by 2, right? Okay, so look, you have to understand, because we're actually, this is a little bit confusing because we're under the x-axis. This is actually a negative quantity. Okay, that length is, it's a negative quantity. So it's we called it y, but it's a negative quantity. Okay, and I want to get positive length for this one. Right, so what should we do? Do you see that it's going to be, okay, you can see that it's going to be 2. 2 is what? 2 is the length from here all the way to there, right? That's 2. Why don't we subtract y? But we don't subtract y because y is actually what? Negative, right? We actually have to add y. That's the expression for this. Because y is a negative quantity, we have to add it. So we actually end up subtracting. Or I can write it as y plus 2. Okay, it's confusing, but you also know from slope, right, that this height right here is, right, that y minus of this point's y. What is this point's y? -2, right? So -2. Maybe that was easier. Y plus 2. Right? Rise over run. Remember? Rise over run. Okay, so this is this right here. Y plus 2 is this height, and this x minus 1 is this length at the bottom. So what is the relationship between x and y on this coordinate? It's going to be this. X minus 1 squared plus y plus 2 squared. It's got to equal to this hypotenuse, which is 2 squared. That's the equation of the circle. This will always be true. Doesn't matter where you are on the circle, as long as you're on the circle. Okay, doesn't matter if you're here, here, here. It'll always satisfy this condition. Now that was really long for us to come up with an answer. Do you see any pattern by just looking at this and this with this equation? Here's my point on the circle. This is the center. Look. Look. Isn't it this? Delta x. The difference between the x's, the difference between the y's, y minus minus 2, y plus 2, is equal to the radius squared. Okay, that's how you get the equation of the circle. So okay, in general, look, I put here, in general, a circle with center at AB and radius of r is this: x minus this a, y minus this y coordinate, the center of the y coordinate, is equal to r squared. Okay, that's the equation of a circle with radius r and the center as AB.